Problem 37, evaluate um, the integral dx all over x squared into 1 plus 1 all over x exponent 3. So before answering this question, I had to first check with myself what this means because it looked very, very complicated and I didn't know how to go about it. So the first thing I wanted to do, it took me some time, but I first had to just check what the problem was asking me to do or what this means. So there's a ds expression at the top, so but it's not here. And then at the bottom there is an x squared, so there is a function, and then there is something else at the bottom here. There's another function here. So I first had to rewrite my expression so that it's simpler to work with. So if I said 1 all over x squared multiplied by 1 all over 1 plus 1 all over x exponent 3, and then I put my dx here. This expression is the same thing as this one, because if I expanded this, or if I said 1 times 1 times dx is equal to dx, which is on top, x times this exponent this is the same as this one. Okay, so now it's a simpler one. I can go on and apply U-substitution. So I will say, let U be equals to something. But now, what do I let my U expression be? Because now I've got a trickier situation and I've got two options to make my U substitution be. So I learned from someone that I can make my U to be the more complicated equation, complicated function, which is a function under a fraction, which is a fraction or something in a power or something in a root. So in this case, I see that this portion here at the bottom, this one, I can make into my U. So if I said 1 plus 1 all over x, it would be better to then work with. I'll show you just now. So 1 plus 1 all over x. Next, I need to find the derivative of this. So this will be the derivative of u all over dx is equals to 1 plus 1 all over x. So here I need to apply the power rule of differentiation. But before applying the power rule, let me rewrite the power rule so that I can be able to remember it. It can be rewritten as n x exponent n minus 1 all over, oh, no, it's not differentiation. It's the power rule. It's not integration. It's the power rule for differentiation. So sometimes it's really difficult to differentiate the two, but then differentiate, I minus, to integrate, then I add. So that's what I normally use to then remember. So before I apply the power rule, I need to rewrite this equation. So this will be du all over dx is equals to 1 plus x minus 1. So I just took the x and took it at the top. It became a negative sign. Because now that the x is a negative sign, I can then find the derivative of this. So this then becomes du all over dx. The derivative of a constant is 0, so it's 0. So next I will differentiate this part. So the power rule essentially tells me that if I have a function, if I have x here, I bring down the power at the bottom and then I subtract 1 for the power. So the power rule also tells me that x must not be equals to 1, I believe. I might be wrong. Anyway, let me solve this. So this, I bring down the 1 here. So this will be negative 1. Rewrite my x. So it's minus 1, minus 1. It becomes a minus 2. Okay. So after this, I can still rewrite my expression to simplify it. So this will be du all over dx, which is equals to this mess here. So it's negative 1 all over x squared. So what I did, I just took the x at the bottom, then it became a positive sign. So after this, I can see that I can separate these two parts, make it equals to negative 1 all over x squared dx. So now I've got a negative sign here, and then I can remove the negative sign from this side of the expression by dividing both sides. So it becomes negative du is equals to 1 all over x squared dx. So now there's something interesting that happens here. If we observe our equation that we have given at the top here, you can see that I rewrote it as 1 all over x squared. Now I have 1 all over x squared dx. So then I can be able to apply my u substitution here because now I have the derivative of u. So let me rewrite the derivative of u here. So this is negative du is equals to 1 all over x squared dx, so that it's closer and easier to work with. Okay, so here I rewrite my integral as integrating, because now, as you can see, I can still put this as 1 all over 1 plus 1 all over x exponent 3 multiplied by 1 all over x squared dx. Like I said, this portion is now the same. 1 all over x squared is now 1 all over x squared dx is equals to negative dx. So now it means I can apply u substitution into my equation because now it's in a simpler form. So I rewrite my expression. This is the integrand of integrating 1 all over. Remember, now I can substitute this expression with my du. So my du expression becomes negative du. This part of the expression, my 1 all over x squared dx expression becomes negative du. Okay, I want to express everything in terms of u so that I can apply the power rule for integration. I've already said that I want to let my u be equals to 1 plus 1 all over x. So this is the u. So if I put u here, it's easier to work with. I can continue and rewrite my expression as I can pull out this negative sign outside the integration sign and write it as 1 all over u du. I'm putting back this 3 here that you can see because I didn't use it in this u expression. So it's u exponent 3, u exponent 3. So now it's easier to then work with and apply the power rule for integration. From here, I apply the power rule for integration, which can be written as x exponent 1 plus 1 all over x, not x, n plus 1. The reason why I rewrite these rules is because at the exam I don't have a formula sheet. So I know that if I remember these formulas, it will be easier in the exam and I can solve my problems easier. So next, I want to evaluate this part, this 1 all over 3 expression using the power rule. So now I can go on to say 1 all over 3 can be rewritten as u exponent negative 3 du because I moved something at the bottom and took it at the top. The integrand of this, I put back my negative sign. I just changed this so that it's easier to apply the power rule for integration. So this then becomes, so here I want to evaluate this part. So I will evaluate this part separately because it's a bit complicated. So it's u negative 3. Because of the power rule for integration, I add 1 here at the bottom. I also say negative 3. I also add 1 here. So this then becomes negative 2 plus 1. This is u, negative 2 all over 2, negative 2, not 2, negative 2, which can be rewritten as negative 1 all over 2 u exponent negative 2, which is equal to negative 1 all over 2 u squared. So what I did here is I just moved the sign here. It's the same thing. I then moved the top part of the equation. The top part here, I moved it at bottom. Now the sign changed to a positive. I put back my 2. And then now I've got a simplified version of the u. Here, I also applied the power rule for integration. It means that because I have applied the power rule of integration, let me just rewrite this expression so that I can explain this. So it's negative, it's 1 all over 2u squared, close brackets, then I say du. In here, I can see that I've got two negative signs. So it's negative, negative, it cancels. So this is integrating 1 all over 2u squared du. Because I have evaluated this inside expression using the power rule for integration, these fall away, the integration sign and the du. So now I've got an expression that can be rewritten as 1 all over 2u squared plus some constant of integration c, because I'm evaluating indefinite integrals, not definite integrals. Because I have already said, remember at the bottom, we said that we are going to let our u is equals to 1 plus 1 all over x. So in place of u, I just put back my u. So this will be 1 all over 2. I'm separating this. Multiplied by 1, I'm putting back my u expression. It's 1 plus 1 all over 2. I'm putting back this 2 on top here, the power, and then I'm saying plus c. This is the same thing, because if I said 1 times 1, it is 1 on top. 2 times this, it becomes this, and then I put back my u, which is this, which I found at the bottom here, which I found in the beginning here, and then the power 2, which is this one, and then the constant, the constant of integration. I can still simplify this because I can't just leave it as is. So to simplify this portion of the equation, let me just highlight it. To simplify this portion of the equation, I will do it separately and then put it back. So this will then become, what I do is I rewrite the parenthesis. It's 1 plus 1 all over, I made a mistake here. It's 1 all over x to the power 2. So inside, I can further simplify it. So to simplify the inside, I say 1 is the same as x all over x plus 1 all over x squared. The reason why I'm saying this is if I said x divided by x, I know that it's equals to 1. So because now the denominators are the same here, I can rewrite the denominator as x, put back my bracket, then the power sign here on top, and then I then put back this. So it's x plus 1 on the numerator. It's x plus 1. So this becomes my expression, which can also be rewritten as x plus 1 squared all over x squared, because this power applies to both the numerator and the denominator. So now I have this expression that I expanded here. I can then put it back in this side. I can put it back here in this expression so that I can simplify it. So this becomes 1 all over 2 multiplied by the numerator in this portion of the equation all over this whole mess that I found here, which is x plus 1 squared all over x squared by some constant c, which is the constant of integration. So this can further be simplified because it looks very complicated still. So to simplify this, I can rewrite this as 1 all over 2 multiplied by. So this portion of the equation, this one that I will highlight in blue, that I'm highlighting in blue, can further be evaluated because it seems very complicated. But if I wrote it as this, if I said 1 all over 1 and I said divided by x plus 1 exponent 2 all over x squared plus c. It is the same as writing this, because this multiplied by this is this. This part is still this portion of the equation. So this part of the equation is this whole part here that I have. So the reason why I'm just expanding is so that I can also understand and also simplify this equation so that I don't make any errors. So because I have this equation like this, I can go on to simplify it as 1 all over 2 multiplied by open brackets. So because there's a division sign here, if I change it to a multiplication, means I can flip this around. Then this becomes x squared all over x plus 1 squared plus some c, which is the constant of integration. So this then becomes x squared all over 2x plus 1 squared plus c, which is the constant of integration. So in the study guide, I saw that this can also be rewritten as 1 all over 2 into x all over x plus 1 to the power 2 plus c. This is the same thing as this, because this power here applies to the numerator, it also applies to the denominator. Okay, so now just to simplify this whole thing so that I'm able to understand it better and show you how I solved it, I'll go back and explain. So this is the simplest version and this is my answer. So in this equation, I started off by evaluating what the problem wants me to do at the top here. So I expressed everything and then separated it accordingly this side so that I'm able to then apply U substitution or choose my U. Then I let my U be equals to the longer x expression, which is inside something. I found the derivative of U with respect to x. I applied the power rule of differentiation, and then I found my du being equal to dx. So this expression, I see that it is the same as rewriting this equation like this, because this negative du, which is equal to 1 all over 2 1 all over x squared dx, is the same. So I then substituted this negative du here, and then I made my the bottom side of the fraction to be on the exponent 3. After this, I took out the negative sign, which you now see here. Then this is 1 all over u exponent 3 du. After this, I went on to apply the power rule of integration to evaluate the integrand here. I took out the sign, as you can see here. I took this u on top to make it negative, and then apply the power rule of integration, then found this expression. After this, I took the expression and put it back. Because there was a negative sign, it cancelled with this negative sign that's inside. 1 all over 2, 1 all over 2 u squared du. Because I evaluated this already, this parts cancel, these two cancel. Then this become 1 all over 2 u squared plus c. With my u being 1 plus 1 all over x squared, I went on to simplify my equation, substitute my u, which I've already determined. It's 1 all over 2 or half multiplied by 1 all over the u, which became this plus c. I went on to simplify this further. So this question was quite long. To simplify this further by finding the lowest common denominator, by saying that x all over x is the same as this, then found this. I took this back and I put it here. I evaluated this side of the expression here by looking at the division sign, which is here. I flipped the sign, then I got this equation here multiplied by this side, then it gave me x exponent 2, which is this part, x squared plus c, which can be rewritten as this version. So I hope that this long expression helps you solve this question. At least it helped me. Remember that I solve this problem so that I'm also able to understand and I'm able to, apply it accordingly. If you have a simpler way to do this, please drop your comments below, and then I will redo this question with a simplified version. Or I'll try and approach this this question later to just simplify and find another simpler way to do it. But this way helps me then break down the question and understand what's going on.